We're absolutely surrounded by information. Articles, reports, data, most of it just sits there on the page. But what if we can make it come alive? What if we could take a simple document and turn it into a dynamic simulation, to not just read about our world, but to actually interact with it? Well, our journey starts right here, in one of the most important shipping lanes on the entire planet, the Strait of Hormuz. It might look like just a narrow strip of water, but its impact on the global economy, you just can't overstate it. And this number is just wild. Think about it. Roughly a quarter of all the oil that travels by sea has to squeeze through this one single channel. So any problem here doesn't just make a few ripples, it creates a full-blown tsunami in global markets. Okay, so let's imagine a scenario. Let's say a crisis breaks out. The timeline we're about to see is based on a detailed document. It's a fictional scenario, yeah, but it's also frighteningly plausible. It all kicks off in late February 2026. Things go south, and they go south fast. It starts with airstrikes. But then, just days later, merchant ships are actually getting hit. The oil price goes crazy. And by the end of the month, boom, the strait is officially under a blockade. The global economy is sent into a complete tailspin. And we're not talking about some abstract threat. We're talking about real ships with real crews. The MT Skylight, the MKD Viome. These attacks made the danger terrifyingly clear. And sadly, people lost their lives. The economic shockwave was instant and absolutely massive. The price of oil skyrocketed, peaking at $126 a barrel. This was the largest single monthly price increase in history. The world was officially in a crisis. So all of this info, the timeline, the attacks, the economic fallout, it's all meticulously laid out. In this case, it's all in a single Wikipedia article. It's an amazing record of events for sure, but it also makes you ask a really important question. How do you take this static record and really understand what was going on underneath? How do you test different decisions to see if things could have played out differently? Basically, how do we stop just reading about the past and start actively preparing for the future? And this, right here, is the answer. On the left, you've got the source material, a flat, static Wikipedia page. But on the right, that's a dynamic, quantitative model of the entire crisis, built directly from that document. This is the huge leap from passive reading to active exploration. So how is that even possible? This is where the real magic happens. This incredible transformation is all thanks to a technology company called DBbun LLC. DBbun, founded by Yuri Cartoon, has created a system that can basically ingest any source material, in this instance that whole Wikipedia article, and automatically generate a living, interactive simulation that lets us start asking all those powerful what-if questions. Now take a look at this. This chart is basically the law of supply and demand in action. The simulator lets you see that direct connection between tanker traffic and oil prices. As the traffic on the bottom axis plummets, you see the price on the side axis just shoot through the roof. And each of those shapes is a different scenario we can test. And here's where we get to really play with those what-ifs. This shows how many ships are stuck waiting outside the strait. That red line? That's the full blockade, a total disaster, right? 200 ships just piling up. But look at the orange line. That's a scenario where they allow partial exemptions. Notice how that one policy tweak dramatically reduces the whole mess? That is the power of simulation. And this really gets to the heart of it. A quote from the simulator's own documentation says it perfectly. It makes the abstract scale of the disruption concrete and comparable. In other words, we're not just reading words on a page anymore. We're actually modeling these incredibly complex effects in a way we can see, measure, and compare. But it's so important to get this. This technology isn't just about this one crisis. That's just a really powerful example. The potential here is way, way bigger than that. This is about a universal tool for understanding just about anything. And the process itself is just brilliant in its simplicity. Step 1, you feed it any source. Step 2, the system crunches that info and automatically builds a dynamic model. And then step 3, you get to explore, ask your questions, and run all the what-ifs you can think of. And when they say any source, they are not kidding. A super dense scientific paper on climate change, a company's boring quarterly report, old historical documents, even something visual like engineering blueprints or just an image. all of this static information can be transformed into a dynamic landscape you can actually explore. This really changes everything about our relationship with information. We're no longer just consumers of facts. We become investigators of systems, which of course brings us to the biggest question of all. Why does any of this matter? I mean, the uses are almost endless. An energy analyst could model these exact kinds of risks. A risk manager could price insurance with way better data. For a policymaker, it's like a sandbox where you can test your decisions before you make them in the real world. And for students and teachers, wow, what a way to bring these huge, complex systems to life. It all comes down to this fundamental shift. It's about empowerment. Technology like this lets any of us stop being just a passive reader of information and become an active explorer, asking our own questions and finding our own answers in the data. So I'll leave you with this thought to chew on. If you could take any document, any article, any chunk of data, and turn it into your own interactive simulation, what would you pick? A famous historical battle? The spread of a new virus? The business plan for a new product? The possibilities are just truly endless. It really feels like a brand new frontier in how we learn, how we decide, and how we prepare for whatever's coming next.